Okay, with respect to derivatives, what happens when we're given non-functions? Well, remember, what are non-functions? Non-functions are, one way to test is to do a vertical line test, right? When a vertical line runs through a graph twice, you have a non-function. And here's the problem. With non-functions at any given point, let's say this point right here, there's two possibilities for a tangent line. All these, there's two different points. Well, if there are two different points, how will you know which one? So there is a different process for finding the derivative, and that process is called implicit differentiation. And with implicit differentiation, you still take the derivative. So the derivative process in terms of the rules are the same, but every time you take the derivative of a y, you tack on dy dx. So take the derivative of each term, and when you do that, the derivative of x is 1, the derivative of y is 1, but because it's the derivative of y, tack on dy dx, and the derivative of a constant is 0, so we don't have to write anything. And then whatever's attached to dy dx, this time it was 1, so we didn't really have to do that. You're going to divide both sides by the constant coefficient, and then that is how you find the derivative of a non-function. All right, so you take the derivative of each term, and every term where you take the derivative, not every time there's a y, because as they get more complex, sometimes you're just multiplying the y. It's only when you're taking the derivative of a y term do you tack on dy dx. And then you want to get the dy dx term by itself. Okay, let's see if I've got one here. Okay, so that's it for simple implicit differentiation. We're going to do an example of when you take the second derivative implicitly. That'll be the next video.